the first section that we're going to cover deals with the idea of limits. And limits are a very, very important part of calculus, understanding them. They help us do a lot of things. Basically, to me, what a limit means is it is the concept of what happens when we get really, really close to something. You know, how does a function behave as we get close to certain values of x, or certain values of the input. And so to start this kind of concept, we talk about the difference between average velocity and instantaneous velocity. So if I'm driving to work, you know, I drive and, you know, my speed may change a little bit over time, and then I get to work. Probably not starting in the negative part of the x-axis. So I'm driving and, you know, I have to slow down and da-da-da. So just to kind of blow this up a little bit, let me make this a little bit bigger. Okay. So this would be my distance, and this would be my time. And so if I want to know what my average speed was at any place, the average speed between maybe this point and this point, I can compute that using the slope. And if you remember, the slope is just the difference between my x-coordinates and the difference between my y-coordinates. And so the slope here would be the change in my distance divided by the change in my time. And so whenever we talk about your change in your distance divided by your change in your time, that is average velocity. I mean, the way I remember it is it's miles per hour. Miles is distance, hour is time. And so if we want to know the average velocity, we're going to suppose S of t is a function that represents your position, really your distance. So really t is time and s is your position or distance. The average velocity or speed, you know, velocity is really more of a physics thing. Velocity is not only your speed, but it's your direction. So we'll let the physics teacher handle that more. But the average velocity here will be the difference between your times, or the difference between your positions at the second time and first time, divided by the change in your times. So that's how I think about average velocity. Now, at some point, you know, it's very important to think about what happens. What if I want to know my speed exactly at this time right here? Well, if I want to know my speed exactly at this time, then I need to be able to create a tangent line, a line that comes right through here, that just touches at this single point. And so what the book talks about is the fact that this line is what's called a secant line. And then as we move this point closer and closer and closer and closer to and closer and closer to this point, then we create what's called a tangent line. And we'll look at that a little bit more in a second. Oops. I'm not even going to bother. We'll just leave that up there. Yeah, so we want to be able to take this point. Sorry for the ticking. We want to be able to take this point and move it to here so that we can find our instantaneous velocity. Our velocity at that moment in time. Not our average over the whole time. For example, I might have averaged 20 miles, 30 miles because it's horrible traffic in the morning. But at certain points in my journey, I might have been going 60 or 70. And then at other points in my journey, I might have been going 10 or 15 miles per hour. And so that's the difference between average and instantaneous velocity. And in order to, as we build this idea of limits, that's what we need a limit for, so we can push those points really, 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 really close together. If you look, let me pull up your book. This is the textbook. I really like the way that the textbook works. Make sure you download the CDF player. So if you go into my math lab I think on the course home, you've got the browser check, but also when you go to chapter contents, it'll have download CDF player, and so that'll let you view the book, which is pretty cool. And so here it talks about the average velocity. It talks about the fact that average velocity is just the difference in your position divided by the difference in your time. And instantaneous velocity is the speed on the speedometer at that instant. And so it goes through, and here it gives this definition of the secant, the slope of a secant line, which is basically what I showed. It's the difference in your positions divided by the difference in your times. They just use the subscripts 1 and 0 versus 1 and 2. And so you can see this nice little figure here, just like the one I drew. So the difference in these S values is the difference in your position over the distance in your time. Then it talks about instantaneous velocity. It says to compute the instantaneous velocity, we need to see what happens as those interval or the difference in your time goes to 0, where it gets really, really, really close to 0. And so it says the instantaneous velocity is obtained as t approaches 1 from the left and from the right. So that's going to be an important concept. We want to be able to go from both directions. And so you can see here there's this notation. And I'll talk about this later on. But right now let's look at just the average velocity. So I'm pulling up problem number 9 here from the book, which is also in the homework. It gives me a position function. It gives me an S of t, and it wants me to find the average velocity of the object over the following intervals. So the first interval says from 1 to 4. So what this means is if I do my formula for average velocity, that's going to be the position function at 4 minus the position function at 1 divided by 4 minus 1. Now, this will also be the same for all of them, except for the last one. So for B, the only difference is I'm going to be plugging in a 3. And then for C, I'm going to be plugging in a 2. Now, I was messing around with the calculator, and I found a pretty quick way of doing this type of problem. So what I'm going to do is first I'm going to go to the calculator and I'm going to enter in my function, my position function, into y equals. Let me clear this out. Doing some other stuff in there. Alright, so I'm going to enter in the function. It was negative 16x squared plus, I already forgot it, 128t, or 128x in this case. Now, what I can do, I'm gonna show you kind of the long way right now. I'm gonna make sure that my table setup, is on automatic. So what I could do is this. I could go straight into the table, and I've got all the values I need here. So we've got S of 1, which is 112. So all of these numbers will be 112. And then I've got S of 4, which will be 256. We've got S of 3, which will be 240. And then we've got S of 2, I'm running out of colors, which will be 192. So you could do this. You could just go ahead and enter that's 256 minus 112 over 3. This would be 240 minus 112 over 2. And this would be 192 minus 112 over 1. Now, if I do this arithmetic here, so let me move this over a little bit. So here I would get 144 divided by 3, which would be 48. On the next one, if I do the arithmetic of 240 minus 112, I get 128. Divided by 2 would be 64. And on the last one, if I do the last one, I'm going to get 80 over 1, which is 80. Now, I found a way to get my calculator to do all of that work for me. So, once I realized, well, in order to do this too, I figured out S of 1. Because S of 1 is in all of these. You see how all of these have the S of 1 and then here? But this is the X that's changing. So what I did was I said, hey, I'm going to come in here and I'm going to make the actual slope formula. So what I did, I'm going to use a parenthesis here, and I'm going to go into my Y variable. So vars over to Y variables, enter a couple times to bring up Y1. And I'm going to have it evaluate Y1 at any X value, and then subtract 112 from it, not 1012. Oops. Make sure I close my parenthesis properly, and then divide by, I need another set of parentheses, X minus 1. Because it's always X minus 1. Now that I have that equation set up, when I go back into my table, you can see the values are sitting here. So I've got 80, 64, and 48. So that's pretty cool that you can just do that. But basically what I'm doing is I'm telling the calculator, you know, so when X was 4, we got 48, and then 3, we got 64, and then 2, you can see we got 80. And so I'm telling the calculator, I'm going to come back in here and show you, to do the actual formula. And the reason why it works so nicely is because, no, I don't want to say that. The reason why it works so nicely is because every problem had that 1 in there. So that's why I was able to set it up. If it hadn't been like that, I probably couldn't have taken this shortcut. So again, this was over X minus 1. And this, you go to your vars, right arrow, enter, enter. Let me make sure I had that right. Vars, right arrow, enter, enter. Yep. So that's pretty cool that you can do it that quickly. Now, for the last one. The last problem says 1 to 1 plus h, where h is a positive real number. So, to do that problem, oops, I'm going to look at my function, s of t equals negative 16t squared plus 128t. So this is part D, and we're doing the interval 1 to 1 plus h. So the formula, the way we set it up, is we do s of 1 plus h minus s of 1 divided by 1 plus h minus 1. Let me move this over here. So this is, again, the formula for average velocity. So we took the difference in the y values at those values divided by the difference in the x's. Now, s of 1 plus h. That means I'm going to plug in, I'm not even going to do that yet. That means I'm going to come over here and plug in 1 plus h everywhere I see a t value. So, now I need to simplify this. So to simplify this, I'm going to apply the distributive property twice here, which is basically foiling, and then I'll apply the distributive property here. So when you do 1 plus h squared, and you're going to see this a lot, you're going to see like things like 1 plus h squared, x plus h squared, you'll start picking up on a pattern. But I'm going to do the first, and then the outside and the inside, and what you're going to find out is the outside and the inside are always going to be the same. So you're going to find out as you see these, as you do this process numerous times, you're going to see the pattern that it's just going to double itself. And then the last one is h squared. And so I end up with, when I FOIL it, 1 plus 2h plus h squared. And now I'm just going to apply the distributive property. So negative 16 minus 32h minus 16h squared, and then plus 128 plus 128h. Now I'm going to combine like terms. So the negative 16 and the 128 make 112. And then I've got negative 32h and a positive 128h, which ends up to be 96. So plus 96h, and then minus my 16h squared. And so this result right here is equal to this. Now, we've already calculated S of 1 earlier. S of 1, you just plug in the 1, right? Or you let your calculator do it. And it ends up being negative 16 plus 128, which is 122. So this right here will be 122. So now I have got, and I'm going to write it down here so that I have the room. I've got 112 plus, did I say 122 over here? Oh my gosh. Arithmetic, 112. That's 112. But I've got 112 plus 96h minus 16h squared minus 112. So there's that one, and there's that one. Now, the denominator, if you look at the denominator, you've got 1 plus h minus 1, so it reduces to just h. Now I can simplify the numerator. The 112s divide out. And so I'm left with 96h minus 16h squared. Now, since there is a single h in the denominator, I'm allowed to do the following. I'm allowed to divide it out from each term. And so the result I get will be 96 minus 16h. And that would be my answer on part D. Now I'm going to check my time because I don't know. Okay. There was one other one I wanted to kind of show that's like this one, and that would be problem, where was it? Number 10. So if I look at problem number 10, the one in the homework, I think, has an equation like this one, but it wants, again, to do the 1 to 1 plus h for this one. And so whenever I do this one, so s of 1 plus h minus s of 1 over 1 plus h minus 1. So my first goal is to figure out the numerator. I know the denominator is going to be h. It's going to simplify to h. And so if I look up here, the first thing to do that's easiest is s of 1. Plus 30 times 1 plus 20. So this is going to be negative 4.9 plus 50, which will be, what would that be? 50 minus 4.9. So 45.1. Now that I have that, let me move this down a little bit. I'm going to do s of 1 plus h. And that's going to be negative 4.9. Oh no, it was 0, wasn't it? I think it was 0. So I just did that for nothing. Not really for nothing. I just remembered it had to be 0 because the way it worked out. So that's 0, that's 0. So everything zeroes out but a 20. Now, s of 1 plus h will be this. 1 plus h squared plus 30 times 1 plus h plus 20. And the best thing to do on that problem is to leave it like it is. Because On this, now notice the denominator is not going to simplify to h. What's going to happen here is I'm going to have all of this mess right here, the negative 4.9, 1 plus h squared, plus 30 times 1 plus h, plus 20, minus 20 over 1 plus h. Now, the 20s are going to subtract off in the top, and that's going to leave me with negative 4.9, 1 plus h squared, plus 30, 1 plus h, divided by 1 plus h. When I first, was working this problem, I wanted to multiply everything out and do all that stuff because that's how I usually do it. But here, I should have noticed that since the denominator didn't simplify to h, something would be a little different. And so now what's going to happen is there's a 1 plus h that I can take out of each of these three pieces. So all three of those have a 1 plus h that I can take out, which will reduce the problem and simplify the answer to negative 4.9 times 1 plus h plus 30. And you can leave it like that, or you can multiply it out and simplify it. So negative 4.9h plus 30. And so this would end up being negative 4.9h plus 25.1. So you could do that. You could, type it in like this or like this. It'll accept either one. And so that one was a little tricky. Alright, we'll do a little bit more in the next video on those problems in which you type in the really small numbers, or use the really small numbers like 1.001. So, I'll see you in that video.